I'm going to show you the process of designing a schematic and a printed circuit board from scratch, particularly if you haven't ever done that before. So to start with, you don't have any PCB or schematic design software. I'll show you where to download the application that I use the most, which is called Diptrace. And this is it here. Now the thing about Diptrace is I like it, I'm used to it obviously, but it won't take you much, doesn't take much to try it out, so I highly recommend it, and I'm going to show you how to use this. Download it from Downloads. It will cost you nothing. Diptrace freeware. You get 2 signal layers, so 2-layer PCBs, not profit use only, 300 pins. 300 pins means 300 connections on your circuit board, so that's fine for us to start with. We click here, download that, or if you have a Mac, download that and install it. Okay, we've installed Diptrace. There are 2 aspects of Diptrace that are important. We've got the schematic design and the printed circuit board design. The first thing we do is design the schematic, and then that flows on to the printed circuit board. The printed circuit board and the schematic are linked in Diptrace. So in future, if we need to make any changes to the schematic, we can automatically update the printed circuit board and they remain locked together. So here's a blank schematic. Zooming in and out, use the mouse wheel. Drag around to navigate, use the right mouse button. So we'll put a component on, a capacitor and a resistor. We've got these libraries here, and each of these libraries you'll see as you just click around, you'll see that all the components belonging to that library are in the lower window. So in the discrete we have capacitors. Roll down, we've got some resistors here, we'll put a resistor in there, and that's all we need for now. I'm clicking on this, which is default select mode, and using the mouse wheel to zoom in and out, and we can get the right mouse button to drag around. With Diptrace, everything is context sensitive, so it's intuitive. If you want to know anything about a component or change some aspect of the component, you use your mouse and just roll over it and right click. Properties. So we can change the value, you can change the ref description, the name, the manufacturer. We can dive in as deep as you want with that. We'll cancel that. But the thing to remember is it's intuitive. So if we're dealing with this resistor, we click on it and we right click. Dealing with a capacitor, we click on it, we right click. There are no keyboard shortcuts to remember. It's not difficult. So we want to connect those together. We use place wire. And you'll see they remain connected, which is good. It's a rubber band. Now another thing we need to do straight up is rotate components. So once again we right click onto it and we find rotate. Also you'll notice there Control R can be used. So when we get a little bit more advanced, instead of going rotate every time, we just use the keyboard. So that's the basics. Zooming, dragging, rotating, and connecting components. First, we need a 555 timer. Now, how do we find a component in these standard libraries? How do we find a 555 timer? It's, you know, there's too many here. There's so many. There's alphabetically listed manufacturer names. Where the heck do we find it? Well, we have this little feature here, search filter. Click on that, search all libraries, and we're going to look for a 555 timer. See what that does. Okay, with the filter on, it's found all of these components. Now, they're not 555 timers, but they've got the number 555 in them. But we'll see there. That looks like a 555 timer. I'll get rid of that window, and you can see we've got the schematic diagram for the component and the PCB footprint. So components consist of two aspects, the schematic part and the PCB footprint. Oh, and also a 3D model, but don't worry about that. So let's place that one. I will use this common through-hole 555 timer. So there it is. We'll just speed it up a little bit. We click on the component, right click, properties. What have we got in here? Markings, show, main marking, show the value, and additional marking, show ref des. Let's see what that looks like. Oh, we don't see a value there because we haven't given it a value. Properties again. What's the value? That's a 1K resistor. Now I think that the ref des, that R2 there, makes it a little bit messy, confusing, so for now we'll remove that. We won't show that. Show none. There, it's a little bit simpler. The circuit that I'm copying requires 9 volts. And we don't have a 9 volts here, but it doesn't matter because a net port is a net port, and what we name it can be anything. So I'll use a 5 volt, right click once again, and we'll call it +9. So that's what it is. So +9 volts. Got something missing here. The ground should be connected to ground. We could wire it over like that, but we won't do that. We'll have another ground net port like this. And those are common connections, so you hover the mouse, you can see that ground is physically connected. I'll just show you a trick which makes reading the schematic a lot easier in some circumstances. Right click on this network, which happens to be called net 2. Let's call it ground for starters. We'll right click again, and we'll change the color, net color, custom, green. So now our ground is permanently green, which makes it easy to see. That's our circuit. So now we can create a printed circuit board for this circuit. Lots of possibilities, and it all depends on your design constraints, your preferences. So let's get to that. Save. We link to our schematic that we just made. So this is it here. Opened. Mouse control is exactly the same as for the schematic. First of all, we'll go File, rather than New, we'll go Renew from Schematic by Components. And we choose the schematic that we just made, My Oscillator. And it's automatically brought in all the PCB patterns for our components. And you can see all the correct pins are connected as per our schematic. So that's great. We can even have a look at what the 3D models of these components look like just by clicking on 3D here. So 3D preview. Before we've done anything, this is what it's saying. Some patterns don't have attached 3D models. We won't worry about that. Just OK. This is what it looks like so far before we've done anything. So this is our printed circuit board. Close. Let's do an outline for this printed circuit board. Place board outline. As crooked as anything. Let's have a look at that. 3D preview. OK. There's our printed circuit board. To straighten that up, context sensitive mouse driven once again. So we hover over our outline, right click, board points. Let's make that square. 0, 22 mils. This one, 0, 0. Now we have a perfectly square outline of our board. Save that. We'll save as our circuit or our PCB. Done. Now, because we have these rubber bands connected to the components, it makes it easier to arrange them logically. Before we draw any tracks, we tend to arrange the components so they're close to the components that they're connected to. So everything's connected to this IC, it looks like. So how about we put the IC right in the middle, like so. And just drag things around until they look good, and it's up to your preference. Now there's hardly an occasion where I would be using through-hole components because surface mount is so much easier to solder. Even by hand. But we've ended up with a whole heap of through-hole components for this. It doesn't matter. We'll work with it. What would also be nice is some mounting holes. So where are they? Up here, place mounting hole. Right click on whatever component we want to change. We'll make them outer diameter 5 with a hole of 3 mil. Get rid of that one, get rid of that one, get rid of that one. Put another one in the opposite corner. So right click, copy, paste. Mounting holes. So we're fairly happy with the way we've arranged these components. Let's connect them together. So what I did there was I clicked on this route manual, and you can see it draws tracks. That track looks pretty thin. Right click on the tracks, it highlights there with the mouse hovering over it. Right click on it, trace width. It's 0.35 millimeters long. If we wanted to, we could customize that size, make it 1 millimeter. Control Z, undo. Or we'll just make the default track nice and thick for now. So unroute trace. Let's go to route setup. See, we've got the default track width there is 0.35 millimeters. We'll make it 0.5. Default clearance is 0.33. We'll make it 0.35. Okay. So now when we draw tracks, they're a little bit thicker. The thicker the better. Always. Where's our ground? Okay, now we're going to do something good. We'll do a copper fill. We'll make the ground a copper fill on the underside of the PCB. This will be a 2-layer PCB. I'll just show you that. Layers up here, it's 2 layers. We've got a top layer and a bottom layer. We toggle between the layers using this little drop down up here. We're working on the top layer and we're going to put the ground on the bottom layer. So here's our ground. Connect these on the bottom layer. And what we'll do also is we'll have a copper pour up here, along here, place copper pour. So we just use our mouse and draw some sort of outline that we're going to fill with copper. And that'll be our ground plane. And that's pretty an odd shape, but it demonstrates the concept. Enter. Connectivity, connect to net, ground. So now you see our ground trace that we made is actually connected and filled in to the copper pour. Every time we want to update the pour, we use our mouse once again, right click, update. Mouse menu context sensitive. But it's difficult to see our other tracks and route tracks while the copper pour is poured, so for now we'll have our copper pour as unpoured. There we go. Now we'll just continue routing all our other components. That's it. That's our very first PCB. Let's put a silk screen on it. Now here we have our layers, top and bottom layers, and here we have our final gerber layers. So this is our track layers, top and bottom, but these are the actual CAD layers. Top assembly, we're working on our top assembly. Now we'll work on our top silk layer, and we'll put some writing there. And that's it. So we've placed components, we've routed them, we've got a silk screen there. You can see our silk screen is green, so our lettering there is on the same silk screen as the component symbol outlines here in green. Let's have a look at that on the 3D preview. Here it is. Now the reason that that LED and that capacitor is sticking up so far is because the 3D model related to that, attached to that component, is like that. So in order to change that, we're just to change the 3D model. Well, let's do that. Right click, 3D model. Here it is here. So we can move that. Let's shift it down. Minus 5 mils, minus 6 mils, minus 7 mils. There, that's flush with the board. And the LED. 3D model. It's sticking out too far, so let's lower that. Minus 7 mils. So let's look at that. 3D preview. Here we go. It's more realistic. It'd be nice if we had a model for our dip, our IC component there, which is a dip, dual inline package. Right click, 3D model. Now it's a matter of finding a suitable 3D model. Any new component you create, you can associate any 3D model with it, which is really good. This is a dip 8. Dip 8, there we go. Let's have a look at that. Just check that again. Now you can see that it's put the 3D model back to front. We've got our little polarity indicator there, and it's around the wrong way. So we have to flip that around. Flipped around. Okay, let's have a 3D preview now. We're happy with that, so we're going to, it's time to send this PCB off to our fabricator or generate the files in order to make it. How do we do that? We do that by File, Export, Gerber. And that will generate the Gerber files to make this PCB. File, Export, Gerber. Export all will create a Gerber file for every single one of these layers, and your PCB manufacturer will be able to use those to make this PCB. The other file we need to export is the drill file. File, Export, NC drill. And here it's decided that we've got 5 different drill sizes there. Auto generate. Added our Gerber files and our drill file, and that's all that's required to manufacture this PCB. And that's about it. We've created our schematic, we've designed our printed circuit board, and we've generated our manufacturing files. If you found this useful, click the like.